And welcome to Master Talker online class. Today we'll be talking about matrices. Please, if today is your first day of watching our video, please consider subscribing. Okay, a matrix is can I say is a form of arranging numbers, okay, or characters into row and column. Okay, into row and column. For example, if I have A is equal to like this. I have A is equal to maybe A11, A12, A13, up to A1n. Okay, A1n. Then this is the roll. Okay, this one means the first roll, the first column. Okay, this is the first roll. Okay, this is the first row, the second column, first row, third column, up to first row, n column. Okay, so now for the column, I have A21, A31, up to AM1. Okay, so what do we mean by this? This is the first column. Okay, this is the first column. The first column, the first roll, the first row, the first column, the second roll, the first column, the third roll, the first column, up to M roll, and what? So in representation of matrix, we'll represent it, we'll write the roll first before the column. So this 2 means second roll, second column. So here will be what? 3 2 and up to M2. Okay, so what do we have here? A2, second roll, 2 3, A 3 3, A M3. Okay, then we now have what? Up to A 2n, up to A 3n, up to A mn. So that is that. So what do we mean by this? So this is the roll. How many rows does it have? This is first roll, second row, third row, up to M roll. Okay, then for the column, this is the column. This is the column, the first column, second column, third column, up to n column. Okay, so let me give you an example to that so that you will know how to arrange numbers. For example, another example is this is general form. Okay, so I can have that A or anything is equal to 1 2 3 4 5, okay, 6 7 8 9 10 11 12 13 14 15. Okay, so we can say that that this matrix is the matrix of how many rows do we have? 1 2 3. And then how many columns do we have? 1 2 3 4 5. So we can say that this is 3 by 5 matrix. Okay, 3 by 5 matrix. So this is a 3 by, look at the way we use by 5 matrix. So don't forget, okay, don't forget that we mentioned the row first before the column. So if they say what is the position of 8? The position of 8 is what? Let's check it out. 8 is in the second row, but in the third column. Okay, so 8 is what? A2, A2, 3 is 8. Why? Because 8 is in the second row, but the third column. Okay, so that is how to identify that. So an example said okay, they said that the roll is read okay, now another thing we need to know is the leading entries. The leading entries are the first one you are seeing in each of the row. Okay, the leading entry in the first row here is 1. The leading entry in the second row is 6. The leading entry in the third row is 11. So the leading entries here are what? 1, 6, and 11. Okay, so that is that. So we now have a, okay, look at that now. let's take an example. They said arrange the following. Arrange the following data, okay, in 3 by 8 matrix. Arrange it in 3 by 8 matrix. We now have 1, 2, 3, 4, up to 24. Okay, that is A question. Then B question answered hence or otherwise. Identify the leading entries. Okay, so let us do that. We are having a matrix of 3 rows but 8 columns. So how do we get it now? I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. Why? Because the column must be 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 8 columns. So we'll start filling it. Okay, so if filling a matrix, you start from the column, then you cannot get the row 8. So I'm going to have 9, 10, 11, 12, 13, 14, 15, 16, then 17, 18, 19, 20, 21, 22, 23, and then 24. So if you look at this matrix, this is what? A 3, how many rows? A 3 by what? A 3 by 8 matrix. Then the leading entries are just 1, 9, and 17. As simple as that. These are the leading entries. Okay? So the next one, look, let's take another question and then we move on. So the next question we're going to take said arrange the following data, okay, in a 6 by 2 matrix. In a 6 by 2 matrix, and identify, okay, and determine a 3, 2, okay, a 3, 2, yeah, a 3, 2, okay. Then we now have that the matrix 4, the data are 4 minus 2, 0, 8, okay. Then we have 6 minus 1, 1, 2, 4, 4, minus 3, minus 5, 0, and 0. Okay, now they say we should, okay, B said identify, hence or otherwise identify the leading entries. Identify the leading entries. Okay, so that is that. And don't forget that leading entries are always non-zero data. Okay, so non-zero data. So first of all, let us do this. Now they say we should, this is a 6 by 2 matrix, so I'm starting with the 2. So which is what? I'm going to have 4 and minus 2. The columns are now complete, so let me fill in the rows. So this is 0, 8, 6 minus 1, 1, 2, 4, 4, minus 3, minus 5, 0, 0. So if you count the row, 1, 2, 3, 4, 5, 6, 7. How are they 7? 1, 2, 3, 4, 5, 6, 7. Okay, sorry, that is 7 by 6 by 2 matrix. Sorry, 7 by 2 matrix. Okay, so now they say we should identify a 3, 2, which is the third row and the second column. So 1, 2, 3. We are in the third row, and the second column is this. So this is equal to getting minus 1. So now the leading entries are 4, 6, 1, 4, minus 3. Okay, they are the leading entries because 0 can never be a leading entry. Okay, so that is that. So let us continue. Types of matrix. So types of matrix. The first one, The first one is called the row matrix. Okay, the row matrix. Now, what do we mean by the row matrix? A row matrix is a matrix that has just one row. Okay, it has just one row. For example, if I have something like this, 1, 2, 3, 4, 5, we call this a row matrix because it has just one row. Okay, so in a row matrix, we have that that the row is 1. Okay, so you need to know that the row is 1. Then number 2 is column matrix, and the column matrix means that the column is going to be 1, 2, 3, 4, 5, like this. Okay, just one column. We call it what? A column matrix. Okay, so the next one we're going to look at is a square matrix. Number C, square matrix, square. Now, a square matrix is a matrix that is a situation whereby the row is equal to the column. Okay, for example, if I have A of M and M, so it's a square matrix. The row and the column must be equal. For example, I can have 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at this now. This is 3. The row is 1, 2, 3, and the column is 1, 2, 3. So this is a 3 by 3 matrix, and it is what? A square matrix. So a square matrix is any matrix that what has the both row and the column equal. Okay, so that is a square matrix. So number 4 is zero matrix. Zero matrix. Okay, a zero matrix does not have any leading entry. Everything there should be 0. Okay, we don't mind whether they are square or not. Just know that everything in that matrix is going to be 0. 0, 0, 0, 0, 0, 0, 0. Whether they are square or not is not our business. Just know that all the entries in it is going to be what? 0. So the next one we're going to look at is what? A diagonal matrix. A diagonal matrix. Number 5 is a diagonal matrix. Diagonal. Now, for diagonal matrix is a matrix whereby, okay, do I call it? It's a square matrix. It's going to be a square matrix. It's going to be a square matrix, okay, and then the diagonal must be 0. The diagonal must be 0. First of all, it's going to be a square matrix. Then the diagonal will be 0. For example, the diagonal will be a number. Then the right part and the left part, or do I call it the upper triangle and the lower triangle will be 0. Only the diagonal will be a number. For example, if I have A1, 1, okay, 0, 0, up to 0, then 0 here, A2, 1, 0, up to 0. Then the next one is what? 0, 0, A3, 1, up to 0. So if you look at this now, you see that the diagonals are what? Are numbers, okay? But the upper triangle, this is a triangle. If you draw it very well, this is a triangle. So the upper triangle and the lower triangle must be 0. That is how you know a what? A diagonal matrix. First of all, it must be a square matrix. For example, I'm going to have 1, 0, 0, 0. Okay. Then I'm going to have 0, 1, 0, 0. Then I'm going to have, or even 3, anything I like, 3, 0, 0. Then I'm going to have 0, 0, 4, 0. Then the last one, 0, 0, 0, 5. So if you draw this now, you see that what? In the diagonals are numbers, but the upper triangle and the lower triangle are what? Are all zeros. The upper triangle and the lower triangles are all zeros. So that is how you know that this is what? A diagonal matrix. Look at the lower triangle. Okay, this is the lower triangle. So this is what? A diagonal matrix. Okay. So the next one, number 6, is upper triangular matrix. Number 6 is what? Upper triangular matrix. Upper triangular. Upper triangular matrix. Now, in upper triangular matrix, we have that first of all, it's going to be a diagonal. Okay, in the diagonal will be number, then equally the upper triangular will have a number. So what do I mean by that? Let me just give a straight example. I'm going to have maybe 1, 2, 3, 4. Okay, 0, 5, 6, 7. Okay, 0, 0, 8, 9. Okay, 0, 0, 0, 10. If you look at this now, you see that in the diagonals are numbers. Okay, the diagonals are numbers. Then the upper triangular parts are equally numbers. Okay, are equally what? Numbers. So that is that. So only the lower triangle will be 0. In fact, in an upper triangular matrix, the lower triangles are 0. Just note that. First of all, it must be a square matrix, so don't forget, it must be a square matrix, and then the lower triangular entries will be 0. So just note it like that. In an upper triangular matrix, okay, it must be a square matrix, and the lower triangular entries must be 0. So note that. Then now the next one is what? The lower triangular matrix. Lower triangle. Now in lower triangular matrix is the same thing, but in this one now, the upper triangular will now be 0. The upper triangular entries will now be 0. So what do we have? Let's have, for example, 1, 0, 0, 0. Okay, 0. Let me use 5 by 5 matrix. Then I'm going to have here 2, 4, 0, 0, 0. 3, 6, 7, 0, 0. Okay. 3, 6, 7, 8, 9, 5, 6, 0. Okay, how many? 1, 2, 3, 4. 1, 2, 3, 4, 5. So remaining 1. So I'm going to have minus 2, 1, 0, 5, 6, something like this. If you look at this, you see that if you draw your diagonal, this is my diagonal. Okay, if you draw a diagonal, you will notice that the upper triangular matrix, the entries are 0. Okay, then you conclude that it is what? It is a diagonal matrix. Okay, it is a lower triangular matrix. Sorry, it is a lower triangular matrix. So the next one we are going to look at is identity matrix. Identity matrix. Now in an identity matrix, identity number what? Now number 8. Identity matrix. Now the word identity, identity matrix, it just means that what? First of all, it's going to be a square matrix. Okay, and then the leading entries of the diagonal, in fact the leading entries must be 1. Okay, the leading entries, the leading diagonal entries, let me call it like that. The diagonal will be 1. Just know that the diagonals will be 1. So let me give you an example. Let me use 3 by 3 matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. So every other, the lower and the upper, in fact, it is a type of diagonal matrix in which the diagonal, the entries in the diagonals are just 1. Okay, it's a diagonal matrix in which what? The entries in the diagonals are just 1. Okay, that is what we know as an identity matrix. Every other place is 0 except the diagonal, and the diagonal is simply 1. Okay, so the next one we'll look at number 9. Number 9 we'll look at is transpose, the transpose of a matrix. Then we look at the symmetric, and then the screw matrix. Then we are okay. Okay, so the next one is what? Transpose. Now transpose matrix. Now transpose matrix is simply turning the row into a column, or the column into a row, something like that. Let me use an example. If I have that matrix A is equal to what? Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, something like this. Then A transpose, watch. A transpose is simply turn it around. The way this will not be 1. Okay. In fact, carry this one, stand it. Carry this one, stand it. Carry this one, stand it. So let us stand this one. If we stand this one, I'm having 1, 2, 3, 4. You see the way I did it? Let's stand this one to be standing. So I'm having what? 5, 6, 7, 8. Well, let's stand the last one. 9, 10, 11, 12. Okay, so that is it. The row will turn to the column, and the column will turn to the row. That is what is called the transpose of a matrix. Okay, so the next one we're going to talk about is a symmetric of a matrix. The symmetric of a matrix. Okay, okay, now symmetric. Now when we say that something is symmetric, what do we mean? They say that a metric, if all the aj, which is an element of a, is equal to the ji, okay, it's called a symmetric. Now in a symmetric matrix, it simply means that what the element in the upper triangular is the same thing as the element in the lower triangular. Okay, the element in the upper triangular is the same thing as the element in the lower triangular. So first of all, it's going to be a square matrix. That is the first thing you will know. That here. So what do we have? Symmetric. So symmetric matrix. For symmetric matrix, what do we have? We are having that. What am I saying? We are having something like this. Watch. First of all, it's going to be a square matrix. So I'm going to have 1, 2, 3, 4. Let's do 4 by 4. Okay. 2, 3, 5, 6. In fact, let me have 7, 8, 9, 10, 11, 12, 13, 14. I want to check something. This is my diagonal. Okay, this is my diagonal. Once you bring out your diagonal, 2 is here, 2 must be here. 3 is here, 3 must be here. 3 must be here. Okay. What else? In fact, this is 2, 5, 10, 2, 5, 10, 3, 6, 3, 6, and then 4. You see, so all the elements of the upper entry are the same thing as the element in the lower entry. All must be in the same position. That is when we conclude that it is what? It is a symmetric matrix. It's a symmetric matrix. So the next one is now a Skew matrix, and Skew matrix is known as anti-symmetric. Okay, it's called a Skew matrix, or you call it what? Anti-symmetric. Anti-symmetric. Anti-symmetric matrix. In anti-symmetric matrix, we just have that what? All the entries of the upper diagonal is simply the negative of the lower diagonal. That's all. It must be the same thing, but it must be negative. What do we mean? Look at this. I have 1, 2, 3, 4, 2, 3, 5, 6, 3, 5, 9, 10, 4, 6, 10, 14. Look at my diagonal. Since I have this as my diagonal, now if here is minus, here will be plus. If here is plus, here will be minus. If here is minus, here as that, they will not be the same sign. As simple as that. Okay, they will not be the same sign. If the other one is plus, the other one will be minus. As simple as that. So let us take an example to that, and then we enter into addition and subtraction of matrix. So okay, example. An example said identify the type of each of the matrix below. Identify A, the type. Okay, types of each of the matrix, each of the following matrix, each of the following matrices. Okay, and the leading entries. Okay, so A said 2 0 3 minus 1 3 minus 6 4 1 5 5 2 0 4 6 8 minus 3 1. Okay, let us identify this one. We'll be doing it one after the other. Now if you look at this, is a square matrix, because this is 4 by 4 matrix. It is a square matrix. Now let us take the diagonal. This is the diagonal. Let's see what will happen when we take the diagonal. Since it's already a square matrix, are we having the same thing here and here? No. So A is simply a square matrix. Okay, and then the leading entries are 2 for this side, 3 for this side, 5 and 6. Okay, these are the leading entries for A. So let's look at the next one, B. B said, look at B, that B is equal to 1 0 0 0 1 0 0 0 1. So now, first of all, is a square matrix. And then if you look at this, you see that the diagonals are simply 1 1 1. So it's an identity matrix. So first of all, it's a square matrix, and secondly, it's an identity matrix, and the leading entries there are just 1 1 1. So these are the leading entries there. Okay, so the next one is and yeah, it's an identity matrix of order 3. Order 3 means that it's a 3 by 3 square matrix. Okay, so the next one, C, they say C is equal to, I have 3 4 minus 1 6, just this. This is a column matrix. So D said that D is equal to 4 0 8 1 6 5. This is what? This is 1 by 1 2 3 4. Okay, sorry, this is 4 rows 1 column. Okay, this is 4 rows 1 column, and it is called column matrix. This is how many column? 1 2 3 4 5 6 6 column and 1 row. So it is what? A row matrix. Whenever you have that the row is 1, we call it a row matrix. If you have that the column is 1, we call it what? A column matrix. So for E said 0 everywhere. 1 2 3 4 1 2 3 4 1 2 3 4. This is a 0 matrix, and it is what? 3 by 4 matrix. 3 by 4 matrix, and it is a 0 matrix. So F said 0 0 0 0 0 0 0 0 so, and it does not have any leading entry. I hope you know. It does not have any leading entry. So 0 0 0 0 0 0 0 0. So this one does not have a leading entry, but this is a square matrix. It's a 0 matrix and equally a square matrix, because this is 4 by 4 matrix. So it is a 0 matrix. So the next one we'll look at number G. G said G is equal to 2 1 2 3 0 minus 1 1 2 0 0 0 0 and 0 0 0 6. Okay, now if you look at this is the diagonal. Okay, and the upper triangular and the lower triangular are all 0. So this is a diagonal matrix. First of all, it is a square matrix, and then secondly, it's a diagonal matrix. And leading entries there are what? 2 minus 1 and 6. Don't forget that a leading entry cannot be 0. So the next one, H. They say that H is 6 4 6 minus 1 0 10 3 0 0 0 9 2 0 0 0 minus 6. Okay, so if you look at this now, this is the diagonal. First of all, it's a square matrix before we talk about the diagonal. 1, 2, 3, 4. 1, 2, 3, 4. So it's a square matrix, 4 by 4 square matrix. And the diagonal is, we have the leading entries at the diagonal, and then the lower triangular is 0. And I told that if the lower triangular is 0, then it means that it is what? An upper triangular matrix. I told you that. Once the lower triangular is 0, then it is what? An upper triangular matrix. And then the leading entry is what? 6, 10, 9, and minus 6. So the next one says that I is equal to this square 9, 0, 0, 1 minus 6, 0, 8, 4, 8. So if you look at this one now, this is the diagonal. It is a 3 by 3 square matrix, and this is the diagonal. And I told that if the upper triangular is 0, then it is what? A lower triangular matrix. So this is a lower triangular matrix, and the leading entries are what? 9, 1, and what? 8. These are the leading entries. Okay. So the next one, J said that is equal to what? J said is equal to 2, 4, 6, 8, 4, 3, 1 minus 5, 6, 1, 7, 4, 8 minus 5, 4, 14. Now this is my diagonal. This is my diagonal. And if you look at this now, this is 4, 6, 8, 4, 6, 8, 1, 5, 1, 5, 4, 4. So once the upper triangular and the lower triangular are the same thing, we say that it's what? A symmetric. Symmetric means the same. A symmetric what? Matrix. It's a symmetric matrix. Okay. So that is that. So the last but not the least is the one we have that K. We have that K is equal to 0, 3, 4 minus 6 minus 3, 0 minus 1, 2. And then, sorry, don't forget that in a screw matrix, please, I forgot. In a screw matrix, the diagonal must be 0. Please correct your notes. In a screw matrix, okay, or anti-symmetric, the diagonal must be 0, please. The diagonal must be 0 before you consider that the upper triangular is opposite in sign of the lower triangular. Okay, so I have minus 4, 1, 0, 2, then 6, minus 5, minus 2, 0. Okay, so if you look at this now, first of all, the diagonal is 0. Okay, see the diagonal is 0, and you see that this is 3 minus 3, 4 minus 4, minus 6, 6, minus 1, 1. Where is 5? So this is 5. Okay, 5 and minus 5 and 2 and minus 2. So if you look at this, you will know that this is what? A screw matrix or anti-symmetric matrix. Okay, very, very important. Then we'll now look at addition and subtraction of what? A matrix. Let me check my time. Okay, addition and subtraction of a matrix. Addition. Now, in addition and subtraction of matrix, okay, we add or subtract row by row and column by column. And then, before you can add or subtract a matrix, okay, the matrix must be in the same dimension. In fact, the dimension of matrix A must be equal to the dimension of matrix B before they can add or subtract. Once their dimensions are not the same, then they cannot add or subtract. What do I mean by dimension? If the matrix of A is 1,7, that is 1 row 7 column, the dimension of B must be the same thing before they can add. Once they are not the same thing, they can never add or subtract. Okay, so an example to that said, example, it said let A be equal to a matrix of 1, 2, 3, 4, 5, and 6. Okay, and they say that B is equal to a matrix of 7, 8, 9, 10, 11, and 12. Ah, that is that. They've taken the lights, so let's on our gen. Nigeria.